We're going to start out the screencast by creating a new project. We're going to use the command line app template to create the new project, and we're going to call this the comparator example project, like so. Alright, so to begin with, what we're going to do is we're going to create a new class, and this class we're going to call person. Inside of the person class, we're going to add a few attributes. We're going to give this person a name, and we are using encapsulation here. And also we're going to provide with this person with an age. And we're going to make sure that we have a constructor that takes as parameters a name and an age that we can use to assign to our attributes. So we'll assign the parameter value name to our attribute name, and we'll assign the parameter age to our attribute age, like so. Alright, so to start out, actually we are going to recap on something we covered in a previous screencast. So what we're going to do is we want to be able to sort person objects. Now we already learned of a way to do that. What we could do is we could say that person implements the comparable interface, and as this was a generic type, we had to specify that it was comparable with respect to person objects. And we're going to implement the compare_to method that we are required to compare. And here we can just do a simple evaluation based on name. So we'll return this.age minus the age of the object that we're comparing with, like so. This way we could go into main and we could create a couple of person objects. And we could provide them with some ages as well. So I'm just going to quickly copy paste this just to save ourselves a bit of work. And remember to change the variable names and change the names over here just so that we have some difference. We're going to give this one the age of 1 and this one an age of 15, like so. Now we could create a list containing person objects as a new array list. And we're using the diamond notation here, so we don't need to write the type for our array list since it's already specified for our list type on the left side over here. And then what we could do is we could add our person objects that we just created. So we'll add P1, P1, P2, and P3 like this. And another thing that we're going to do is we're going to make sure that we have a textual representation of person objects that makes sense. We can achieve this by overriding another method. We're going to override the toString method. Like so. And we're going to return just the name of the person. Well, actually, no. We're going to return the name and a white space and then the age as well. Like so. Alright, with that out of the way, what we can do now is we can do a system out print line of the persons array. Then we could use the collections class and call the sort method on that, because since our person objects are comparable, we implement the comparable interface, we're able to specify here that we would like collections to do a sort of our person list. We need to remember to import collections. And then we can print out that again and see that hopefully it has reorganized our persons list. So let's run this program just to see. All of this is recap. So we see here that we have initially our unsorted list where the objects appear in the order that we added them to the list. And then down here we see that we have the persons ordered by ascending age. Now, imagine that we were in a situation where we would actually need to sometimes order them in ascending age and sometimes order them in descending age. There's a limitation in the use of the comparable interface because with the comparable interface we only provided with one way of comparing person objects. To this end, we can use the comparator interface. So how do we use the comparator interface? Well, we'll start out by creating a new class, and the sole purpose of this class is to compare objects. Okay, so we're going to create a comparator class, and this comparator class we're going to call person age comparator. Inside of this class, what we're going to do is we're going to implement an interface, and this interface is the comparator interface, and the type that we're going to compare is person. So this means that since comparator is a generic type, we need to specify person inside of these diamond notation here. And we're going to import the comparator class, and we're going to implement the methods that it asks us to compare, and we'll only implement this one up here, the compare method. So the compare method pretty much works like the compare to method. So this means that the compare message, we need to return an integer which is positive when O1 is larger than O2, which is negative when O2 is larger than O1, and which is equal when they're both equal. Now, when we are doing an descending order, we need to flip that. So this means that what we're going to return here is we're going to return O2 dot, oh, and here we forgot that our attribute up here, the age attribute, is private, so we need to add a access method for that. So we're going to do a public int getAge inside a person, and we're going to return age inside of that. Alright, so now we are able to get the age from outside of the class as well. So here we're going to say getAge minus O1 dot getAge. With this done, we've created a comparator. So now we need to use this comparator, and the way that we're going to use it is we're going to go into our main code here, and we're going to create a new variable of type person age comparator, and we'll just call this PAC as an acronym. And we didn't specify any constructor in it, so we can just use the default constructor. Now we're going to use the Collections.sort again, but this time we're going to use an overloaded version of it, where we're going to provide not only the list, but also the comparator that we call PAC. And then we're going to do a system out println and see if the logic worked out for us. So let's try and see what happens when we run this program. And as we can see, now the order is flipped. And that's because our person age comparator flipped the two person objects so that we get the opposite result of before. So what was previously the largest is now the smallest. The result we see down here, we see that now we have a descending order of persons. And this means that we can create any number of comparator for one particular type. We are no longer limited to only using a single comparison as we were with the use of the comparable interface. We can indeed create any number of person comparators. We could compare on the length of name, for instance, or the beginning letter of the name, and so on and so forth, to any extent that we wish, as long as we create a new person comparator for each case. And of course, we can just pass along to the sort method here in collections the person age, the comparator that we wish to use on our list. So this was a short screencast on the use of the comparator interface.